you have to remember what the equation is. Well, slope is the change in y over the change in x. When we set these things up, it was just a matter of finding slope and going from there. Now, when we found and worked through slopes, we did it a few different ways. We set it up when we found it via a couple of different points. We did it from a graph sometimes. From the graph is the easy way, but when we want to look at an exact example, just so I don't have to keep making numbers up, it's easier to look at ones that are pre-made. Real fast, slopes. If I'm going to find the slope of that, the easiest thing to do is label it real quick. And this is one of the things that Mrs. Thorne and I were talking about. A lot of times when you just label something, it makes your life easier because everything you need to know is then there. Don't fight against it. So just label them out. Here's your first x, first y, second x, and second y. And then fill in the blanks. That's it. It is a 6. Yeah. So it's 6 minus nothing is 7 minus 1. Now I know we had harped about this whole calculator thing. We have not received them yet. You guys gotta buy a calculator. You need the one with the fraction bar on it. You need to know how to press the buttons to make it work. I saw so many absolutely stupid mistakes on a quiz. Like -3 minus 3 was 0. Try again. Okay? -21 plus 7 was -28. Guys, these types of things should not be happening. You need to get a calculator. You use the fraction bar, you put things in the right order, you're going to be okay. All right? So here you wind up with 6 over 6, otherwise known as 1. Okay. Now, if we took that one step further, which we did, write the equation of a line that is given 2 points. Well, when you want to write the equation of a line into, remember what we called slope-intercept form? Slope-intercept form, y equals mx plus b. We always write when we're done, in that format. The reason why we write it into that format is because it's the easiest format. Because as you guys get into next year, you have a button on a calculator that says y equals. It's quicker to graph that way. But in order to convert, in order to get to that, the one way we had to do that is we used point slope form. So this point slope form allowed us to get to slope intercept with one step. So if we're using this as our example of write the equation line given 2 points, well, we just found the slope because that was your first step. And now we can just substitute in and go from there. Yes, sir?
One thing I was really confused about on the quiz, and it's like, I'm sure I wasn't the only person, and but okay, so in that equation,
Yeah.
with the x, we don't substitute anything in, because I was just like, what?
What do you mean?
Like, no, just like the x, not the x1.
Mm-hmm.
We don't substitute anything in.
No.
Okay, because I got really confused.
No,
I was
because
like,
remember, this is the whole idea. This is the whole idea when you have a point, some point,
okay.
and a slope. That's why it's called
I
point
just
slope.
got like super confused about
Did
that.
I ever substitute in the values of x and y?
No, look at your
Nope.
notes.
Look at your notes.
Look
Yeah,
at your
exactly.
notes. Yeah,
Okay.
open phone.
Is it in your notes like that at all?
Okay, I'm gonna have to look at my sloppy notes.
That's the idea, guys. Don't make up your own methods.
Right. What's going on?
Just not worry about it. Again, going back here, you have a slope and a set of points. Does it matter which one you use? No. It does not matter whatsoever. Which one's going to be easier to use? The 1 and the 0. Because it's easy to subtract 0. So I substitute in y minus 0 is my slope, x minus 1. And then finally, what's y minus 0? Whoa, y. And you just get an x minus 1, because 1 times that doesn't change it. And you're done.
I've seen that a lot. People want to do the y minus 0 equals 0. You guys, so if that's confusing because y is a variable, just plug in a number. Let's say it's 2. What's 2 minus 1? I'm sorry, what's 2 minus 0? 2. So it's not 0, right? So it's just whatever that number is. So in this case, it would be y. So sometimes that helps.
Great.
On your shoe.
So somebody had gum, and I decided I felt like wanting to step in it, so.
So now every time you step.
Today's a great
that?
day.
What do you mean, keep the one in for x?
Oh, could you write y equals 1x?
No, can you explain, what were you saying? Yeah, absolutely, absolutely. There's nothing wrong with that. Her question was, can she put the 1 in front of the x? Does it change anything? No, nothing wrong with that. Okay? Nothing wrong with that at all. All right, let's try another one. Same deal. Should be a -5, excuse me. Let's do the exact same thing, where we're going to write the equation of the line given 2 points. Remember, when we write the equation of the line given 2 points, what's the first thing you need to find? Right, find out their slope. So, like we've said before, when we write it out, show what you're doing. Write down the formulas, write down the equations. You're going to find your slope first. Slope formula, change in y, or the change in x. You have all the information right there. Relabel it if you like. Make sure you don't mix things up. You don't flip-flop stuff around. First x, first y, second x, second y. And fill in the blanks, guys. When you have the formula in front of you and everything's labeled out, it's a matter of quite literally filling it in, because you know where everything goes. 1 minus 4. -5 minus -2. Now, like I've been saying, for those of you guys that wind up with the calculator, there's a fraction bar. And you quite literally put this in the fraction bar, and it does everything for you. Move this over so you can see. If I type this exactly the way that it's written, 1 minus 4 over -5 minus -2, and hit enter, it does the work. I don't need to do anything. But the advantage is, I have a calculator. I know the ones that I had the other day, they're just regular old boring calculators. This has the fraction bar. This is the, obviously, the multi-view one. Okay, it does the exact same thing as this one does. All right. If you have that multi-view, you shouldn't be getting any of these things ever wrong, ever.
How many of you have that? Raise your hand if you have the multi-view.
I mean, mine does.
So I'm not sure.
Find it. $15. You should have them hopefully this week. Bless you. So my calculator told me that this is equal to 1. Is every slope going to always be 1?
Yes.
No. It just happened to be dumb luck that the 2 examples I just came up with both had a slope of 1. So when I go back into point slope form, does it matter which set of ordered pairs I use? Either one of those to write the equation.
One
No.
doesn't matter.
It never matters.
Okay.
It does. It just this slope could have been 73, 1/5. It doesn't matter. Whichever one of these ordered pairs you want to use, go ahead and use it. Okay. It doesn't make a difference because you should, hopefully, get the exact same answer. All right. So if I substitute in, I'll just use the first ones because it's already labeled. First point. Rewrite it through. So it's y minus 4 is 1, x minus a negative 2. Now, that portion in the calculator, that portion in the parentheses, your calculator won't do x minus negative 2 and simplify it for you. You have to know what that means. Minus and negative always means it is plus, okay? So when you rewrite, you're going to get y minus 4 is x plus 2. And then how do you move a negative? You add it. And hopefully 2 plus 4 is 6. Okay. Sora, did you do it with the other point?
I sure did.
Perfect.
Did we get the same answer?
No.
Yay, we
Yes.
math.
It doesn't matter which point you pick, you guys. You pick any point, you plug it into point slope form, and just slope it down, and you'll get the same.
As long as you substitute incorrectly, you're gonna get the same result, guys. That's the idea. Okay, that's the idea. Then the last little bit, as it really started to get off the rails, if you will, is when we started doing stuff like this. There we go, there we go. Write the equation of a line that is parallel. Write the equation of a line that is perpendicular. When we did this the other day, last week, for what, 2-3 days? Yeah, at least 3 days. We came up with a 3-step way of doing stuff. Those of you guys that wrote down the 3 steps, which amazed me that not many people did. You just kind of try to go with it and write it out, which setting yourself up not to do well right away.
Who remembers the 3 steps? What's the first step?
Original slope.
Yeah, find the original slope. What was the second step? Yeah, find the parallel or the perpendicular slope, depending on what the question is asking. No, all this is the equation. Yes. Then we plug it into point slope form. Yes. Third step, we're just plugging it into point slope form. That's it.
That's it. So as I'm looking at one like this, you always want to identify what your original slope is. Well, what's the original slope? Negative 2. All right? So as I go through the process of this, my original slope in this problem is negative 2. The instructions will say, is it parallel or is it perpendicular? This one says it is parallel. So what's the parallel slope to negative 2? Good. And now we just write out our points. This is our x, and there's our y. Our x sub 1, y sub 1, if you will. Y minus a negative 4 is our slope, x minus the negative 5. Too many of you guys are not rewriting this very next step. You're trying to move all the negatives and stuff like that. Rewrite it as addition first. Rewrite it as addition before you distribute through. You're making the silly mistakes with your signs. Okay? Y minus a negative 4 is the same thing as saying y plus 4. Same thing inside the parentheses. And now you have to distribute to both parts on the inside of the parentheses. Remember the very first couple of days of the school year, we did a lot of quick algebra problems where you had distributed properties and whatnot? The reason we were doing that is we were going to do this right away. Okay? That was the idea. So as we go through that, we distribute through. And then how do you move a positive? Good. Okay. Move that up so you guys can see the back.
Any questions on this?
So the other thing that happened a lot,
Any questions on this?
the other thing that happened quite often was the exact same question. Like Madison was just mentioning, when you are given right off the bat either a horizontal or a vertical line. For some strange reason, the mythical horizontal and vertical line is the most difficult for students to work with. Why is beyond me. Because personally, it's the easiest. I believe it's the easiest. It's the quickest one to worry about. Because you have, as long as you understand what it looks like to start with, you're good to go. Okay? So let me show you what happens here. Now, when we have, can I go to a clean one? Is everybody all caught up on this?
Yeah, sure.
When you have a horizontal line, every single, guys, every single horizontal line looks the exact same. It goes from left to right. Always. Every single horizontal line also has one thing in common. It's slope. The slope of every single horizontal line is always 0. The slope of this is always 0. The equation of every single horizontal line is also always going to look like this. Y equals some number. Okay? Always. So if this was going through an ordered pair point at, let's say, 4 and 7, in that ordered pair, which one is the y coordinate? The 7. So what would the equation of that line be? You know, y equals 7. So this example would be y equals 7. That's what that would look like. Now, excuse me, if I wanted this line to be parallel to an ordered pair of -3 and -2, what kind of lines are parallel to horizontal lines? Horizontal lines.
All these blue lines in the papers that we're talking about?
Gee, wasn't that convenient to remember?
That was good.
Remember, horizontal lines are always y equals a number. Horizontal lines are always parallel to other horizontal lines. Horizontal lines are always y equals a number. So when we wrote out, remember I said when we wrote out horizontal parallel to horizontal, horizontal or vertical parallel to vertical, y equals a number is parallel to y equals a number, and so on. That's the idea. Once you recognize that you know you have a horizontal line, what's parallel to horizontal lines? Horizontal lines. What's the y value in this ordered pair? -2. Go to the next problem. What kind of lines are perpendicular to horizontal lines? Vertical lines. Back to the red line on your paper. I think everybody in here is using lined paper. Nobody's using just a blank sheet, right? If you look at that, you've got that red tab line on your piece of paper. That's perpendicular to every single one of those blue lines. Every single one of those blue lines are horizontal lines. So if I wanted to be perpendicular through that point, -3, -2, what would the answer be? X equals, very good. X equals -3. Because if it's perpendicular through this point, it would be x equals -3, because it goes through here. Okay. Let me write out again the ideas between how these things work together. Okay. So if we have, wait, put it on this sheet here in a second. Yes, ma'am.
Okay, so, I'm sorry, this might take a while to grasp.
It's okay, it's okay.
So, I
You're
mean.
not the only one.
Okay, good. So, with the equation y equals or x equals, it doesn't matter what equation it is, it's not just y equals a number and then there's no numbers after. Like,
You mean that y equals mx plus b? Are you upset that that doesn't look like that?
yeah, like I'm confused. You can use that with any equation that we get on the test.
dmx plus b,
Well,
or the point slope you're talking about?
well, yeah, right here. So you can use that with this.
No.
No.
That is not a horizontal line
Okay.
or a vertical. That's just a regular old
Just
run-of-the-mill.
trying to like figure out where.
Yeah. This stuff is like the addendum. It's
Okay.
the sometimes thing.
Mhm.
What you're thinking of is that this always will work. Okay? That will always work, even if you have a slope of 0. Okay? Actually, this won't work if you have an undefined slope. You can't use this. But if you have a slope of 0, you can still substitute in 0 for m. What's 0 times x? 0. So it goes away. You wind up with y equals a number. Yes, sir.
How would you use that one if all they gave you was like -3 and -2? Because they don't really know what
You'd have to start with an equation. For example, if I start with an equation of, let's say, x equals 6. What kind of a line has an equation x equals a number? A vertical line. Okay. Vertical lines are always x equals something. So I know this has to be a vertical line. Vertical lines are always x equals something, and they have a slope that is undefined. The reason that their slope is undefined is because when you have a 0 in the denominator, you can't divide by 0. That's how that works. So these guys all have a slope that is undefined. And if I wanted to be, let's say, parallel to 3 and 6, well, 6 and 2, 3, -7, what kind of lines are parallel to vertical lines? Vertical lines. Remember, vertical lines are parallel to every other vertical line. If you look at all these little grout marks in the tile, or in the bricks, excuse me, all of those lines are vertical. Each one of those is parallel to one another. Okay? Each one of those parts. If you look across all the, bless you, all the left to right lines in the grout for the cement of the cinder blocks, those are all horizontal. Each and every single one of those is parallel to each other. Where these two lines intersect, they're perpendicular. It looks like that little T symbol that we show. So horizontal lines are always perpendicular to vertical lines. Gee, isn't that a nice cheat sheet that's in front of you every single time when you see that? You start thinking about it. So if I want to be parallel to x equals a number, what would that, excuse me, what would be parallel to x equals?
And everybody
Another
says
x equals. So what does x equal in this ordered pair? 3. So it would be x equals 3. If I wanted to be perpendicular through that point, if I wanted to be perpendicular, excuse me, to an x equals, my answer would have to be, very good, it has to be a y equals.
You got it. Oh my gosh, you got it. You got it. You got it.
What's that? For this one? For parallel? Yeah, you just take the x coordinate. You're just taking the x coordinate because what I want you to because what I want you to think of when you're seeing these things is if you just go back to the idea of knowing what a vertical line looks like. If you have a plain old boring vertical line, what did I say was at 6? There's your vertical line at 6. If you had the ordered pair, what did I say was 3 and -7? 3, -7. If I wanted to go through that point at 3, -7 and be parallel to that, obviously, again, I need to have another vertical line. But then that just reminds me, okay, vertical lines are all x equals some number. What does x equal in this case? I did it at -3, -7. Excuse me.
Yeah, you're good. It should be positive.
Sorry about that. Sorry about that, guys. And you do that. So in the back of your mind, you're just remembering, hey, that's a vertical line. What's parallel to that? Other vertical lines. What's the equation of vertical line? Oh, it's already x equals something. If I wanted to be perpendicular, I just spin around the other way. I go this way. For some reason, and I don't know what it is in the brain, because it is more of a shortcut method.
It is a shortcut, yeah. And I did the long cut method here. The long cut, is that even a word? I just totally made that up. So this is the long cut
No,
method.
my kids say that all the time.
Well,
Hey, let's take
shortcut,
the
here's
long
cut.
cut
Yes.
home.
So here's the long cut method. Stop, tell the kids.
No,
what I
seriously, my
said.
kids say that all the time because
Okay.
they want to stay outside longer. Let's take the long cut on our bike ride.
So here's the point. So this is the example that Mr. Murphy did where he put up the .47 and saying it's a horizontal line and it's a slope of 0. So the shortcut method is, so all horizontal lines are y equals a number. What is the y here? The y is 7, so y equals 7. If you wanted to do the algebra, because I love algebra, so I wanted to do this, I just went and wrote the equation for point slope form. I put in my points of 4 and 7. There's my y. There's my x. My slope is 0. And then I get to distribute 0. Well, anything times 0 is 0. Is that correct? So then I got y minus 7 equals 0. To get the y by itself, I add 7 to each side. I get y equals 7. So here's the algebra. So you could see why it's that way. Right, here's the little part of the distribution. So does that help kind of to see that too? So we're showing you the shortcut. You don't have to do all this. Okay, but here's the long cut.
Nobody saw
I just wrote that in my notes.
Did you write long cut?
Yeah.
Yes.
Okay.
No, I didn't make it up. In the directions, it said for this problem, I don't know, Mr. Murphy, if you can go back.
Oh, sure.
He said it was a horizontal line. He said there's a horizontal line that goes through 4, 7. So it goes through this point. So you have to know, so there's some memory work here, you guys. You have to know that the slope of every horizontal line is 0. You need to memorize that the slope of every vertical line is undefined. That you have to know. Okay, so once I know that, I go, okay, a horizontal line, slope is 0. Now I can plug it in, now I can go ahead and do my algebra. And then I get to here and I go, dang, that's what Mr. Murphy told me. So horizontal line is y equals a number.
And remember, guys,
Oh, yeah.
you're going to be given an equation to start with. Sometimes it'll be y equals 7, sometimes it'll be y equals 3x plus 2. All right, and it's just a matter of going from there.
Yes.
So if we already have m equals 0, then why can't we just put y equals 7 away?
Exactly.
Bless you.
It's exactly what Mr. Murphy was showing you guys, right. Just go to y equals 7, but some people were struggling with the fact that why does it look that way?
Right.
So this is the long cut to show you why it works that way. Do you need to do this? Absolutely not. You see the shortcut, right? I just say y equals 7, it's a horizontal line. But for some people, I think it helps to kind of see that process.
Yep.
Yes.
So what would it be if it was a vertical line?
So if it's a vertical line. so
If it's a
how-
vertical line, it would say x equals something.
Yeah.
Vertical lines always start as x equals 3.
Would it like give you a slope top?
It might say write the equation of a line that has a slope that's undefined and it goes through a point of blah blah. And you just write down x equals blah. Okay.
And I wouldn't do a long cut for that one.
No,
Because I
there-
couldn't write, how do I write that something's undefined?
Yeah, and
I
that's the
can't.
difficult thing
Yeah.
with the undefined ones. So if you're given I don't know, give me an ordered pair. 7 and 2, and your slope is undefined. And I just want to write the equation of the line that goes to that point with a slope that's undefined. So that just means in the back of your head, remembering
Remember, yeah.
that a slope that's undefined is a vertical line. Guys. And every single vertical line always starts the same. It's x equals something. What does x equal in that ordered pair? What's your answer? That's it. Then you go on your own happy way. Yeah.
Are you ready for this? What's the slope of a line that's perpendicular to this line?
Y equals
Y.
People are just used to this class being hard.
What's that?
People are just used to this like class being hard, like everything is so like right on all this, but now it's easy.
It's not just that. It's everything's a little bit different for everybody. Everybody has their own style. Everybody has their own personality. It's just a matter of getting accustomed to the subtle nuances, if you will, in math. I mean, those of you guys that are in foreign language stuff, French and Spanish and all that, the nuances within the language is what makes the language.
But it's foundational to do any kind of parsing out or translating. You have to have that foundational knowledge. You need to know what those verb endings are.
And the idea, once you start to understand where you put the accents, where you emphasize certain things, the structure of that, that's how you're able to learn to speak other languages. You know, even your own personal accent gives you, I don't want to say flair, but it's the same idea with math. It's the subtle nuances that are within stuff like this that isn't technically written out in that long form, that long cut form, but it's the idea that you understand the subtlety of it. So that's where a lot of this stuff comes from. Let's do another parallel, I think, or let's do one more. The other one that I know that we had a problem with was when you had, let's see if I can scroll through here, find one, where you had to solve for x, or you had to get y by itself. For example, let's do this. Let's go perpendicular through -1 and 5. Through the line, 2y is 10x plus 2. Let's write an equation of the line that's perpendicular through the point -1 and 5. Through the line, 2y equals 10x plus 2. What a lot of people had forgotten about stuff like this is that when you find your original slope, in order for it to get the original slope, you have to have what by itself? Y. You gotta get y by itself here, guys. Because it looks like it's in slope-intercept form because it's got the 2y equals, but it's setting you up to make sure you remember to get the y by itself. So how do you get y by itself? Divide by 2.
Every term.
Everything gets divided by 2. What's half of 10? Bless you.
And now we go through our steps, right? What's the first step? What are we going to write? What's the slope of this line? 5. And then what's the second step?
Perpendicular.
Yeah, perpendicular parallel. What do we want?
That's perpendicular. So it'd be
Change
1/5. It would be negative 1/5.
Negative 1/5.
-1. Very good.
And now we
Change, flip.
plug it in, plug it in.
Change and flip. Change the sign, flip the fraction. Y minus 5 is -1/5 x. Can I write it as just +1 right away? Okay. Distribute, very good. So we have y minus 5 is -1/5 x minus 1/5. Now, back to using the calculator. I have to add 5 to a -1/5. If I'm looking at just this via common denominator, what's the common between 5 and a 1? 5. So if I just multiply that second one, top and bottom, by 5 both, what would you get? 25 over 5. So right, in essence, what I'm doing here is -1/5 plus 25 over 5. Bottoms are the same, so what's -1 plus 25? 24. My final answer would be y equals -1/5 x plus 24 fifths, or over 5. Now, remember when we talked about this last week, when we had these fractions, we weren't trying to give you something that was just going to be awful that you had to put together. These were very straightforward, where you only had to multiply by 5 or 2s or something just to get a common denominator. We try not to make them all messy. Let me show you where I threw the homework for tonight. On the geometry tab, chapter 3, at the bottom, I have writing equations worksheet. I'm gonna label this as, I'll retype in here in a minute, Tuesday's homework. Pop it open, bless you.
Do the entire page?
I'm getting there. What I want you to do is, let's do the evens starting at 6. Evens, I think it's 6, and I think it goes through 24, I want to say. Yeah. Now guys, I left in here solutions. You're gonna be able to check your work. What I want you guys to do is to look at it, go through them. Don't just write down the answers, because I know if that's what you're doing, okay?
I'm gonna show your work on your sheet tomorrow for you.
Does that work? And we'll practice more parallel perf stuff tomorrow than today, okay? Yes. On Friday? Well, we're doing it Thursday. This was last week.